Good morning, class. I was weak. Good morning, everyone. So how's it going? It's Friday, midterms. I heard you guys have fluids. Tuesday? Okay. All right. Well, what can I say? Good luck on your midterms, we're almost halfway done with the entire quarter. And then yeah, basically, sorry for scaring you with the lights. Yeah, so basically, it's Friday, it's week 5, we're halfway through the quarter. Last week I went kind of hard on you guys, had a meeting with Dr. Barsanti. So this week will be easy for y'all for the lab, but I really need y'all to do me the favor of trying to finish both the scripts for the lab today. Try to finish before you leave. So I promise it'll be easy. And if you finish early, just stick around, study for your fluids, do your homework for this class. Make sure you finish everything before you leave. Please, if you can do that. Because after your midterms for your other classes, then it's going to pick up for this class again. So this week will be kind of chill. Next week will be continuing on, and then it's going to pick up real quick, really fast. So yeah. Basically, I have you guys started this warm up. So this is kind of just continuing from last week. This is the same as last week. And so hopefully, ideally, you can use your previous code to, hopefully you can use some of your previous code. Ideally, you should be able to just copy and paste the code and then just simply change the name of the function, or call the function with the same name, and then just input the matrices for this example. That's what I want you. That's what I want y'all to get used to doing, kind of like building the scripts and then automatically inputting whatever code you have. And then I also want to practice real quick calling the ijth elements of a matrix. So let me just build a simple matrix real quick. Okay, so let's just kind of practice. So everyone take a look at this element right here. Hopefully you'll, and then let me share my screen. Yeah, hopefully y'all can see that, right? Yeah, so we have a 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So we have a 5 by 5 matrix, right? So let's say I want to call just the first value, 0.7577. So how would I call that? Yeah. So I'm gonna call this matrix. I'm gonna call this M, and then let's say I want that first element, and so I'm just gonna say that's just A11, right? So same name, M11. Okay. So there we call that first element. So let's say we want, I don't know, this element, right? So this is 0.5497. Okay, so we're in, which row is this and which column? Because this is what we're getting confused about, the rows and the columns. So we're in the 4th row, 2nd column, good. So we do rows, comma, columns. So if I want if I want that one, I'm gonna do the 4th row and the 2nd column, okay? So that's how we get that element, okay? So as you can see, this one is matching with that one right here. Let's say I want the entire third row. So how would I get that? Yes, good. 3, comma, colon. So that gives me the entire 3rd row, like you said, right? So I'm going to run that. And then as you can see, it matches the third row. And so let's say I want the fourth column. So how would I get the fourth column? Yeah, so now I switch that column is going to be, I believe it's like that, right? Colon basically gives you the entire row or column. So this is that column. That's the fourth column. Okay, so if you're still a little bit confused about calling the matrices, that's still okay. It's only week 5, but definitely take some time this weekend to review the appendix problems, and then try to automate that with the for loops as well. Okay, so it's basically it's a little bit tricky, but it's really important because that's how we use the for loops. All right. Any questions about that? All right. So let's get started with the lecture, basically. So like I said, we're going to be continuing. This is basically chapter 4, solving systems of linear equations. So hopefully for most of y'all, this is review. And so again, you're my Friday class. So it's a little bit tricky because ideally you should have, at least started the homework by now, right? So the Wednesday class gave me some tips to help y'all. So it's going to be slightly different today, but hopefully it makes a lot of sense. And then if it's going too fast or too slow, then just let me know how to keep up the pace. So last time we covered Gauss elimination method. So how did we do that method? We started by writing the augmented matrix, and then we proceeded with the algorithm, right? So what was the algorithm for the Gauss elimination? Yes, okay. Yes, exactly. So we have a pivot equation, and then we proceed with that algorithm. So we will be kind of reviewing it today because, as it turns out, the rest of the algorithms are really similar. So today we're going to be doing LU decomposition, and then if I don't go over the methods, definitely review those because they're going to be on your exams. So what is pivoting? So what is a pivoting method? So why would you need pivoting? So basically, if there's a reason, for instance, if you're dividing by 0, you would have to pivot that equation. So I won't be going pivoting today, but if you need help, then let me know. But please study it anyway, because like I said, it's going to be on your exam. So it's in your best interest to review that. All right. And then also inverses of a matrix. So for your other classes, you're going to need inverses of matrices. So, and also for this class, you might get tested on that. So definitely review those, and also the iteration methods. All right. So there's also several other ones like LU decomposition with Kraut's method, and then LU with pivoting, but really they're all similar to Gauss elimination. So we're going to kind of review, kind of what we did last time. So if we have a system of equations, in this case, we have how many equations and how many unknowns? Yeah, 4 equations and 4 unknowns. So therefore, our x and our n is 4. So n equals 4 in this case. And so what we did was we wrote the matrix form of the equation, and then we wrote it in the reduced form, aka the reduced echelon form, reduced matrix form, et cetera, et cetera. And then we have this upper triangular matrix in this case, right? So you'll see that triangle. So yeah, and then once we have it in this matrix form, then we back substitute, and then we use the equations to back calculate the results of the matrices. So some of y'all didn't get credit last time because you didn't quite finish the problem. So the purpose of doing the Gauss elimination is to get the x's to calculate the unknown values. All right. So any questions before we move on? Okay. So basically, we're gonna do LU decomposition, right? So let's say we have this system of equations. Okay, so in this case, it's the same. This is straight from your book. So we're gonna go over it slowly today. And I really want you guys to understand the math. And then once you understand the math, how do we translate that into code? Okay, so as usual, we're gonna first start by writing this in matrix form. Okay, so we have the matrix A. So what is gonna be A? Matrix of coefficients. X is your unknowns, and then B is the right-hand side of the column vector. Okay, so LU decomposition. Why do you think it's called LU decomposition? Yeah, so the L stands for lower, and the U stands for upper. Yeah, so make sure you see that, because again, you're gonna get tested on this. So this is a lower triangle, okay? And this is an upper triangle, okay? So do we see that? Lower triangle, the upper triangle. So make sure you understand the theory, because the theory is for your exams, and then the applications are for your labs and your homework. So what do you notice about the ones right here? Or what do you notice about that diagonal? Yeah, so you have ones on the diagonal on the lower. So the lower has ones on the diagonal, and then you have your zeros down here on this lower triangle part, and the zeros up here. Okay, so this is only, so some people are a little bit, not sure what this is. This is LU decomposition, so we're only decomposing A. So we're kind of ignoring X, and we're kind of ignoring B for now. We're only going to focus on A for now. And then we're going to transform A into L and U. Yes. So we're going to talk about that. So to answer your question, the A, this is going to be your upper triangular matrix, which is part of your Gauss elimination. So these are your new terms of your equation. And then M is going to stand for multiplier. All right. So we're just gonna jump right into understanding how to do this. So decomposition simply just means you're kind of like factoring out A. Okay. So for today's homework, all you have to do is calculate LU, but then LU is going to have other applications as well. So LU is going to be useful if you want to calculate your inverse. It's going to be useful if you want to solve your system of equations. Good question. Any more questions before we learn how to do this? All right. So we're going to get started. And then let me know if I'm going too fast. And so, like I said, the Wednesday class gave us tips. So we're going to try using a pen and paper this time. Okay, if I wait, let me see what do these do? Y'all can see that? What does that do? Yeah, go ahead and close those for me. Thank you. Which one do you like? This one's number 1. This one's number 2. This one's number 3. Number 2? Like medium. Okay. All right. So yeah, hopefully we can see that. I wonder if I can control the camera. And give me a second while I move the camera. All right, I'm gonna stop this video and then pin this one, pin that. All right, okay, this is great. So except you can't see everything. Sorry, Zoom. You're gonna have to wait a little bit. That thing is blocking it. All right. Well, hopefully you guys can see that. So we're starting by writing our matrix. And then, yeah, we have our matrix. And then we're just going to kind of proceed. So just kind of do whatever you think you normally would do to starting with the Gauss elimination, right? And then let me get my notes as well too. Just in case. Is that a -6? Is it? Second row, first column. Yeah. Yeah. Okay. So let's go. Let's do this together. So what do we want to do is basically we have AX equals B. And the goal is to decompose A into L and U, whereby L, yeah, and then let me know if you guys can see that. Yeah, I think you guys can see most of that. Whereby L is the lower triangular matrix, which looks like this. 1, 2, 3, 4. M2, 1. M3, 1. M3, 1. M4, 1. All right, that's L. And U equals B upper, which is A11, A13, A14. So I think what we should do is we should do this once manually, once, and then automate it. Triple prime. 0, 0, 0, 1, 2, 3. Okay. So, well, should we do the upper one first? Because that looks pretty familiar. So we can do the upper one. So let's do this. We're going to have a couple pieces of paper. So the first step is we need to look at first step is to look at the first row and the first column. Okay, the first row and the first column. And so that's going to be like this. So here's our matrix, and we want to ignore everything else. So our focus is only on this part of the matrix. And so we want to delete these numbers. We want to get those zeros such that we match this lower part, this upper triangular matrix. So how do we do that last time? So I'm going to rewrite it just so we see it. 4, -2, -3, 6, -6, 7, 6.5, -6. Okay. So what is this called? Good. This is the pivot equation. And so this is the equation that we want to change. So we're going to say that our new equation, which we're going to call E2 prime, is going to be So what should we do to the pivot equation? I'm going to multiply the entire pivot equation by so I want to cancel out this -6 with this +4, and then I'm going to subtract the equations. So then I should put I'm just going to take this number and this number, right? So let's do a little side calculation. So if I want to have -6 minus something times 4, so what, and this has to be equal to 0. So there's a question mark right there. There's a question mark that I want to cancel out these numbers so that it's 0. So if I put the 6 right here, if I put the -6 and the 4 right here, the 4 cancels out with that one. -6, +6, 6. That's 0, right? So I took the bottom number and I put it on top, and then I took the lower number and I put it on the bottom. So you kind of flip these if you want to see that in your head. You flip these, and then so in this case it's going to be right, that's going to be 0. And then I want to do the rest of the rows, but I want to do that on MATLAB because, you know, we have some decimals, but that should cancel out. So if you like the MATLAB way, we can do it on MATLAB. But in general, we have E2 prime is going to be E2 minus, in this case, it's -6 over 4 times E1. So this is our first equation. Okay. So that's going to update this row. So this 6 is going to turn into 0. This 7 is going to turn into something else. 6.5 is going to turn into something, right? So we updated that row. And then we do the same thing again. So now we can say, if we want to generalize this a little bit, we can say let I equal 1, okay? And then let j equal, so what should j be? So how do we think about like what's j? Because we looked at the first row and the first column, but we're looking at the second row. So I'm gonna let j equal 2, okay? To kind of have an idea of what to automate. So then we're gonna say that the new matrix, so in other words, EJ, right? For just this first case, EJ is going to be E, let's call it EJ prime. EJ prime is EJ minus, in this case, now we're looking at, so what is this -6? So this is -6. So we have a fraction. So this -6 is going to be on the top. So this is going to be the second row, first column. And this one's going to be, that 4 is going to be first row, first column times EI. So in other words, this is the new equation. This is the old equation minus the multiplier times the pivot equation. So what's the multiplier? Where m, let's make that a lowercase m. M is the multiplier. So what's the multiplier? That's just like, we're just defining a number, okay? And then P is the pivot equation. So it's really difficult to explain how to derive these equations. So some of you guys think that I memorized these. Some of you think that, you know, I just kind of know it. But you guys y'all have to learn how to derive these equations yourselves. So if you want, you can use this equation. Let's box that one. Or you can think about the MATLAB way, or you can think about the matrix way. So we have three ways of conceptualizing this. We have just the numbers. Let's just call this the matrix way. And then we have the math way with the equations, and then we have the MATLAB way. So whichever way you like, just stick with that and then practice the other two. So the matrix way, we just defined the two vectors, the two arrays, and then we just subtracted them with the numbers. And then the math way, we defined some equations, and then the MATLAB way, we're going to define them into MATLAB. Okay? So that being said, let's jump into MATLAB and let's see what this looks like for the first equation. Oh. Okay, I'm going to leave it like that so we can make sure we all see the same thing. Okay. So we have our matrices. I'm going to define A as that, B as that. It's the right-hand column, the coefficients, matrix of the column. Okay. So the first thing we said, just make sure that runs. First thing was said was we need to change this guy into a 0. Okay. And so our equation was, let's do the MATLAB, let's do the matrix way first. So I'm gonna, you know what, in fact, we can manually, let's do really manual and then update the whole thing. So instead, this one, no, let's not do that. That's a bad idea. Let's just update it like this. A, 2, comma, colon. This is the matrix way. Matrix way is going to be 2, comma, 1. It's very, very general, very first step. 2, comma, 1 is going to be that element, which was -6. So if you wrote the equation, I'm just going to copy the equation. So that's just going to be -6 minus -6 over 4. So hopefully that should be 0. Outputs to 0. Nope. -6 over 4. -6 over 4. 4 cancels out. Minus 2, comma, 1, first, second row, first column. Yeah, by the first one, by the 4 times the 4. There we go. Cancel out that 4. Okay, so that one changed. So that's that first 0. Okay. So, well, you guys let me know. Do we want to finish the rest of the row first? Manually? Yeah, let's do it manually. So now let's look at, now we're going to change A. So what are we changing now? If my goal is to change that second element. So what element is that in the matrix? 2, 2. Okay, perfect. So it seems like we're on the same page here. So that's 2, 2. So what goes here? So I'm going to put a 7 there. 7 minus. So look, that's going to stay the same. That's going to stay the same because that's our multiplier. And then now what goes right there? So remember, we take the next part of that first equation. It should be a -2, right? And -2. Okay. So now I want to automate this a little bit. I'm just going to say, let's update the entire, comment that out. Let's update the entire. So how do I update an entire row? You told me during the warm-up. Two comma colon. Good. Okay. So in the first case, we did -6. Then we did 7 from up here. So we're trying to get. Now I'm going to apply the equation. I'm going to do step 2. That's the matrix way. I'll just do the math way. So I told you the equation was new equals old minus the multiplier times the pivot. So what's the multiplier? Good. Do we see that? Raise your hand if you understand why the multiplier is -6/4. Yes? So it's this one. That's going to stay the same. So that's the multiplier. So what's the pivot? So that's going to be the first. That's going to be the first row, right? Pivot is the first row. So how do I write that? Yeah, I heard y'all. So that's the pivot is 1 comma colon. And then so the old equation is just going to update to the new equation. So that's going to be our. That should work, right? Let's see. Does it make sense so far? Right? So hopefully this is making sense. Now I'm going to go a little bit faster. I'm going to automate this now. So I'm just going to say, so this is our multiplier. So this is our multiplier. This is our pivot equation. So what are we going to do after this? Yeah, we do it again. So what's going to be there? Yeah, 3 comma colon. Look, I don't have to do anything else. See? Because the multiplier stays constant. The pivot stays constant. So now this should go to 0. No, the multiplier changes. The multiplier is going to change, actually. So what does the multiplier change to? So you take the bottom number, you put it on top, and you take the top number, you put it on the bottom. Should be 7/4, right? No? I need to see what's my A originally. Originally my A was a 1. Was that a typo in the code? Right here. Should be a 1. This one. So I think it's a 1. 1 over, what was that? 1 over 1/4. I think that should be good. Okay. So we do one more time. So now we have the -12, right? And then we're gonna go to the second column, do it again, third column, do it again. So any questions before moving on? We're gonna keep going. So this is our M, this is our pivot, and this is our equation that we change. Okay, let's go back to the math real quick. Okay, so now we updated this and this. So now we have this part. We have these parts, okay? We have the first part complete. This is complete. But we also have the multipliers. Should be M32, M42, M43. So we have these three multipliers and we have these three zeros and we have the A1s. So now we need an algorithm. So this is the algorithm. Algorithm. So what's an algorithm? It's just a list of steps of how to make a cherry pie, right? So what's the first step? Yeah, first let's define the matrices. So we have A equals that. Make sure you're careful with your capitals. And then B is whatever, right? And then if we want, we can define the augmented matrix, AB. So I want to do some for loops. So I need to tell MATLAB. Tell MATLAB how many rows? How many rows? How many columns? So it's only for LUD comp, so we're only going to look for the A. So this is just a 4x4 matrix. So we have 4 and 4. Okay. And then I'm going to go into MATLAB and then I'm going to type how to define that. And that's going to be the size of A. Okay. So how do we proceed? Now I want to do a for loop. I want to iterate this. So I want to start. First we started here and we're looking at the second row. And then we're in the first column. So the first column, let I equals 1. Okay. Second column, second row, let J equals it's 2. So how do we generalize that? There's always going to be, I plus 1. And then we iterate that. Okay, let's make sure we understand this. Let's go back to MATLAB. So let's do a timeout. So this is going to be a for loop review. I'm just going to ask you guys. So if I type this, what's going to happen? Yeah. So y'all know what's going on. So say again. So we're gonna start. Hello. This is the for loop, right? And then it's gonna enter the for loop. I is gonna initialize at 1 and then increment by 1, right? Yay, we are out of the for loop. For loop. Happy face. Okay. So if this runs, you just get increments. So we're reading the code. So like I said, we're reading the cherry pie, steps of the cherry pie. Step 1. Hello, we're in the for loop, and then now we're outside of the for loop. Okay. And then if I do nested for loop, what's this going to say? So what is this going to do? Okay. So this is going to be I, and then this is going to be J. So I go to the very top. What's the first thing? In fact, let's go one at a time. Let's just do once. So what should this be? So I is equal to 1, J equals to 1. So nothing special, right? I equals 1, J equals 1. That's it. So if I say I equals 1, J equals 3, what is that going to do? Yeah. It should say I equals 1, starting at I equals 1, J equals 1. And then look, we're down here. So it says end. We go back up to the top. Let's write this one out. Let's write these ones out. Back to paper. Let's do, I'm just going to call this A. I'm going to call this B, C, and D. Okay. No, let's just do it. Let's just do it manually. So for I equals 1 to 1, for J equals 1 to 3, output I, output J, and end. So let's start. Everyone watch. No coding. Everyone either think about it or watch. So we're going to start I equals 1, J equals 1. Back to the top, back to the top. J equals 1 plus 1, 2. I equals 1, J equals 2. Back to the top. I equals 1, J equals 2 plus 1, 3. Now we're done, right? Couple more. Let's do a couple of these. I equals 1, 2, 3, 4, J equals 1, 2, 3. Output I, output J, and end. I equals 1, J equals 1. Back to the top right here. Increment J, what is J? I equals 1, J equals 2. Back to the top, I equals, J equals. Good. Now we're out of this for loop. We go to the top right here. I equals 2, J equals. Okay. Did I go too fast? Raise your hand if that made sense. Let's keep it going. So now we're at what? J equals 2, J equals 3. And then we're back to the top. I equals 3. I equals 3, J equals 1. Back right here, J equals 2. Back right here, I equals 3, J equals 3. So by the end of it, I equals 3, J equals 3. Okay. So let's make sure that's correct. J equals 1, I equals 1. This is the beginning. J equals 1, I equals 1. What is the top? This is the top. This is the top of the for loop. Hello, this is the for loop. I equals 1, J equals 1. Constant, change. Constant, change. This one stayed as 1. That was the first one. Let's do the second one. at the top. Constant, change, constant, change. We change I equals 2 now. Going down, j equals 2, I equals 2, j equals 3, change I, right? So if this doesn't make sense, all I can tell you is you just have to go play with the code. And then you have, guess how much time you have? You have about 5 weeks to get this down, right? Because we're halfway through. So if you don't get it by today, that's okay. You can do it the math way. So that being said, any questions? I know that was fast, but I think y'all got this. Most of y'all took C++ already, so I think y'all got this for the most part. Okay. Go back to this class. Any questions about for loops? Okay, let's go back to this class. Where are we with our math? So our goal is to write an algorithm so that we want to change these to zeros, and we want to change these to ones over here, and these ones are zeros, and then the multipliers. Okay, so that's our goal. So basically, you know, it's hard to explain unless I just give the answer away. So this is just kind of how you do it. So I say the rows, comma columns. I define A, I define B, and then I say this is the size of A. Okay, and then I want to initialize the for loop from I equals 1. So how high does I go? Yeah. So that's going to be 4 rows. Because after we increment I, it's going to go to this row, doing all these rows. You kind of just have to see it. I mean, if you practice it, you'll see it. Trust me. So this is going to be the rows. So rows equals size of A of 1. So that's not going to work, but in other languages that should work. This is C++. So we're going from 1 to the size of rows. So what should that be? If I output I, what would that be? Yeah, it's going to be I equals 1, 2, 3, 4. Good. So the rows is 4 and the columns is 4. And then I'm going to do a nested for loop. So I need for j equals. So the first time we did it, j was 2, right? I wrote I equals 1, j equals 2. So I can do it from 2 to rows. But I'm going to do I plus 1. Okay. So I plus 1, and then j will increment based on that. J plus 1 up to the number of 1, 2, 3, 4 rows. Okay. So after I do this, the first step, the second step is to calculate the multipliers. Calculate the multipliers. Okay, so I'm going to put this step right here. The step goes right here. So how do I calculate the multipliers? So I'm going to call it M. So what do we notice about the multipliers? Right. So do we see a colon in the multipliers? So the multipliers are just a constant. So multipliers are just a constant. So this is just a constant. Calculate the multipliers, which is a constant. So if I have a constant, I'm just going to do, let's see. Do I do j comma I or I comma j? Let me verify that. Let me verify that. Why do you think I comma j? So the first multiplier was minus 6 over 4. So I equals 1 and j equals 2. So I'm going to be in 2 comma 1. It's actually going to be j comma I. Yeah, good try. You're good. So what is that going to be equal to? That's going to be equal to so this is why I want to try paper first, because I need to define M. I need to initialize M. Initialize M as A. That's just nothing. That's just telling MATLAB what it is. Okay. And then I'm going to say, look at M. Let's call this U. Sorry. It's going to be the upper. It's going to be the upper. J comma I. Okay. So this is going to be the A. So this one was the bottom over the top, right? So that should be U of the bottom is J comma I. So that's 2 comma 1 over 1 comma 1, right? Yeah. This is 1 comma 1. 1 comma 1. So that's the multipliers. So if we run that, that should give us the multipliers. Let's try that out. I'm going to comment out. I'm going to comment out everything right here. Okay. So here's my new code. I'm going to ignore all this stuff. So hopefully with my algorithm, it should work. Multipliers, J comma I. I'm going to initialize U. Upper. U. This is my second one divided by my first one, right? Should be I comma J. I comma I. Yay, we are out of the for loop. I'll put M. Let's see if that works. Okay. So that's the same code. That's this. So we did it. We wrote the multipliers. Don't worry, I'll go back. I want y'all to pay attention to the understanding what's the math. We wrote the multipliers and then we calculated the multipliers. So what's our last step? We should know that from last time. Yeah, we do the Gauss elimination, right? Second step, third step, calculate the upper triangular matrix. So this is from Gauss. This is constant. And then I'm going to put this right there. Gauss. So how do we do that last time? Last time we did OG, but this time I'm just going to call it upper. That's going to be J comma colon equals. So we're applying this equation. The new is the old minus the multipliers times the pivot. So ideally, the multiplier should be correct. I want to do it again. Make sure. Oh yeah, that should work. So now that we have the multipliers, that's part of the equation. So that's like right here. This equation. So I'm going to plug this equation into the MATLAB form. I'm going to copy and paste this equation. Copy that right there. That's going to be same thing, U of J comma colon minus the multiplier, which was J comma I, and then times the pivot equation, which was the I comma colon. I comma colon. Okay. So these are the only two equations we need. Already got one of them. Let's plug in the other one. So now we have our algorithm. This is U, J comma colon, J comma colon, minus M of J comma I times U of I comma colon. Output M, let's just say M is the lower, and then U. Output U. So I gave you the homework. I'm not supposed to give you guys the homework, but this is the homework. Are we done? We're almost done. So here's our lower and here's our upper. We have one more step. We just have to transform these zeros across the diagonal. Okay? So I know we did, I know that's fast. I know, you know, the code, there's the I and the J. But if you apply the algorithm, this is how you derive the equations. Last step, get the ones for me on the diagonal. I need these ones. And then that's your homework. And then everyone should get full credit. Okay? Any questions? So you guys can study that. Let's go over some theory real quick. Because for your exams, for your labs, you need application. As engineers, we apply the principles and we solve problems, right? But for your exams, we're gonna have to learn the theory. So we need the theory. So she might ask you like some tricky things. I don't know. In undergrad, you know, finals week, pulling all-nighters, right? So my friends and I, this is a story time. My friends, we just said the Uxie-Buxie method, like Uxie-Buxie. I mean, I don't know. It worked. You can call it Luxby, you know, just think about it. But instead of memorizing it, it's better just to practice it. Okay? So think about where these equations apply. So I'm going to plug this into A. Yeah, you can call it Uxie-Buxie. And then, you know, I talked to Dr. Barsanti, talked to our professor. So last time, these problems are in your book. And then you have some extra credit this week. So go ahead and think about where you can apply these principles to your engineering classes. And then hopefully after this class, you can apply them for your other classes, right? So you can have like some chemical systems, electrical, mechanical. Yeah. And so before we go into the labs, you know, I'm a fan of study tips, but I want to know, you know, it's been 5 weeks. So 5 weeks ago, I read your comments. Y'all said you all were hesitant about taking this class. But I think y'all are doing really, really well. So what are your study tips for this class? Don't be shy. Study groups. So work with friends. Know the math, know the equations. I like that one. What else? Okay. The other class said like read the examples in the book. They're pretty good. And so everyone do me a favor. Everyone get out your laptops. Open up Canvas. Open up Canvas. Check your grades. Let me know if there's something that you're not comfortable with, because right now it's week 5, and it's gonna get harder from here. Okay. So all I can say is just study the homework, study the quizzes, because you guys have exams, and then check the syllabus. If you're stuck, do it by hand first and then transfer it to MATLAB. And then, like I said, so you have one extra credit problem this week. I don't know, strengthen numbers. So if you email the professor, maybe she might give more extra credit. Yeah. And then, yeah, make friends. You can ask me questions, ask Dr. Barsanti questions, come to my office hours. They're on Thursdays, and that's pretty much all the tips I can give for now. Yeah, so if you're not comfortable with your grade, see me as soon as possible. So I apologize that MATLAB grader is like not the best, but I think it's decent enough. That should be good. All right, any questions? So let's check the lab. So if this moves, that means you guys are cheating. So I'm gonna see if you guys are cheating. Let's see. Don't cheat. Okay. So yeah, just get started in your labs. This one's gonna be a review. Hopefully the labs are easier. This is gonna be a review. So if you did this by hand last time, I want you to program it. And then this one is also gonna be a review. So this one, ideally, if you automated it last week, you could be done by now. And if you're done by now, go ahead and do me a favor, stick around for at least the next hour, study for your fluids, study for your whatever classes, and finish the homework. And then you guys can take off for the weekend. Okay, I'm gonna stop recording here. Certainly.